Evolution is often thought of a process that takes millions of years, but that's not always the case. Single cell organisms, in particular, ride an evolutionary fast track. Within weeks, a population of bacteria can virtually reinvent itself. In recent decades, this phenomena has pitted doctors and researchers against mutating bacteria in an anxious battle over antibiotic resistance. Experts now estimate that as many as 2 dozen types of bacteria have evolved resistance to most, if not all, antibiotics available today. A battle that we have been winning handily for 50 years, thanks to advances in medicine, appears now to be an even match. Start the microbe clock to see bacteria in action. So we have someone that is just sneezed. Now, this is going to go for 12 hours on the clock, but notice that the bacteria in 2 hours have already doubled in numbers. It keeps going. Notice the numbers up here. The replications are in the millions. Is the population. The population is going to go up exponentially. And here is the number of mutations. Here's the important part for this. So we're going to watch it for 30 more seconds. And we'll look at what that key is, where it says view key, so we can see what the different colors mean in this model. And remember, this is a computerized model of someone who just sneezed and what's happening to the bacteria that they expelled. So we have 5 more seconds. So we started out with a handful in terms of population. In 12 hours, there's been 13,753 replications. So they reproduce really, really quickly. And there are 13, almost 1,400 mutations over the course of these replications. So now let's look at this key. So we have what was originally sneezed out were the red. So the red is the same as the first generation, right? So they replicated. There was no, there wasn't issues with that. The second generation are the generation that comes from these guys, right? So we're looking at the yellow. Third generation is the pink. And now we're looking at mutations. So these little blue lines show colonies of bacteria that have already mutated. Now, that mutation may make it resistant to the antibiotic. So I'm just going to read this part. Some bacteria are more resistant to antibiotics than others. If a population of bacteria is treated with an insufficient dose of antibiotics, which means they're not given enough antibiotics, resistant bacteria will survive and continue to replicate, doubling their numbers in just 20 minutes. So every 20 minutes, the size of the colony doubles. And those bacteria that are replicating are the strong ones. They're the ones that the antibiotic is not killing. Each time the same antibiotic is used, resistant bacteria will make up an ever larger percentage of the overall population. Mutations can increase antibiotic resistance further by strengthening the resistance of individuals. In time, these individual changes will strengthen a population's overall level of resistance. So in a very short period of time, they replicate, form bigger and bigger colonies. Those bacteria that aren't being killed by the original antibiotic are stronger and they keep multiplying. So in this petri dish, eventually you would have more and more of the blue because they would be the mutated bacteria. And so that's why we get very, very concerned that if you're given a prescription for antibiotic that you finish the entire thing, because even though you're feeling better, the bugs that are left in your body are the strong ones. So take all of that antibiotic